Yo, what's good, guys? Welcome back. Another day, another video. Shout out GitHub followers as always. Appreciate all of you, bro. I be looking every single day. I be refreshing the GitHub. I won't lie. Something's wrong with me. I just had 400 megs of caffeine, so I'm a little bit hyper. I just realized. I didn't even realize that until I started recording. But Pokemon sound of the day. That Pokemon today is Oddish. Let's get into that, shall we? Side note. I played some poker yesterday, and I won $16. I'm the GOAT. So, make sure to sub for that, because I won $16. I actually lost it all last time, but I won it back, so. Okay. Wait, I gotta listen to that one more time. I don't really remember what he said. Oddish. That was terrible. That was not good. Alright, let's get into the Leetcode of the day as always. This is my favorite part. I'm not gonna lie, guys. I like seeing it. Please don't be hard. Please don't be String compression 3? Should I do the first two? Let's try to do the first two. This is probably an easy problem. Oh, and it's a... Okay. Well... Is this not easy? How is this a medium? 56? Am I tripping? Is this just easy as fuck? Hold on. 4 C in chars. Wait, is this easy as fuck? This feels easy, but maybe not. So the way I want to go about it, I just want to do exactly what it says. Like, I'm going to go here. I'm going to read this A. If the next character is the same as the previous character, then I just update the count. If they're different, right, then I just append the count as a string and the letter before. But if I want to do that, then I think I need to pre-compute this first one. Oh, it's after. The 2 is after. Oh, and it's a... Wait. Return 1 in the first... Wait, am I returning... I'm returning an int? Wait. Huh? 1, 2... Why is it 6? The group lengths are 10 or longer. Modifying the input array, return the length of the new array. Wait, what? Hold on, I don't want to modify the input array, I just want to do it. So why is it not just the amount of characters inside here times 2? unless it's 1. That's the problem. So why don't I just hash all of this and then, like, okay, let's say I hash this, right? So there's key is A and the value is 2, right? So if the value is greater than 1, then you know there's going to be at least another this character, right? And if the value is 1, then you're not going to have a number. Hold on, let's just make sure. B12. Oh, because it's this is why. I mean, that still follows the same logic. Like, why can't I just hash it? Okay, hold on, guys. So basically, oh, spelled this wrong. So yeah, so basically we're just gonna, have the key as the letter and the count as the value, and we're gonna need to do this somehow. Oh, but this isn't gonna work because there could be A and then A here, right? Maybe I should just read the directions, but instead be stored in the input array chars. Okay, never mind. This isn't gonna work. Okay, this problem's harder than I thought. So yeah, we don't need a string. We don't need a build string. We probably need like a count variable. Damn, 8,000 this. Probably need like a count. Do I need like a previous char? Prev equals blank. Okay, so if not prev, I'm just gonna write some stuff out and I'll try to explain it because I'm not entirely sure how to do this problem right now. If I'm being completely honest, the solution is not in my head. Basically, what I'm kind of struggling with is just trying to figure out how to handle this first letter. Because what I want to do is I just want to keep track of a previous, right? So, because if I get to a different letter, I know that I'm going to have to do some modifications, right? So maybe instead of, I'll do I, because I think I'm going to need the index. It's kind of weird how, easy for readability. Okay. Or easier. Yep. So if not previous, so basically this is how I'm going to keep track. Like when I get to this B, I'm going to have this A, right? That's going to be important. But if obviously there's going to be nothing there at the start. So if there's nothing there, then prev is equal to to C, and count plus equals 1. Right, so now it's A. Elif, right, C is equal to prev, then count plus equals 1. And else, now this is where we actually do the changing. I don't think this is going to work for the last input or like the last thing. Look, yeah, I might like append something there, like chars.append. See, the thing is I'm kind of getting sidetracked right now. Is there a character that will not be in here or symbol? Or symbol. I've actually never tried. Hold on, guys. I'm getting a little emoji kitchen. Get cooking. What is this? What? No, I don't want the emoji kitchen, bro. I just want an emoji. Okay, I'm gonna take this woman emoji right here. Can I put this in? You can. Okay, I'm gonna put this in here because I just need a character that is like guaranteed not to be in this input string. This, I might be overthinking it, but this is like the way I'm gonna handle the last character. Else, why am I modifying the input string though? That's what I don't get. Like, why can't I have another one? Like, can I not have a red or like build? No? Or like one of these. Whoops. Else build dot append prev, and then for num in str of count build dot append num, right? Just to handle the case of like 12, right? And then count, and then prev is going to equal to c, and then count is equal to 1. And let me just print build. Let's see what I'm working with here. That's not cool, bro. Okay, let me just. God dang it. Will it be numbers? Letter, digit, or symbol? Okay, I'm just gonna input a number. 1 or 0. They don't allow emojis on Leetcode. Is that right? Yeah, that looks right. A1. If count is greater than 1, then we can do this. AB12. Isn't that right? Return len of build. Wait, it actually wants me to modify the OG? Or are you being for real? Wait, why is it telling me to return an int then? Return 6, and the first 6 characters of the input array should be... Wait, what? So I have to edit it. It said okay, well, that's not cool. How does that even make sense? It literally says return int. Okay, what if I just return build? What then, bro? So, I mean, I think I have it working, but I'm not modifying the input array. Wait. So what if I do it backwards? So what if I go backwards on this thing? I do the same thing, and I do it like... Okay. I'm doing this so because I'm going to modify this array. I'm going to only add before it, which is low-key kind of worrying because that feels like an O of a million solution, but it's all good. All right. Length. It's just how you traverse an array or list backwards in Python. Okay. And I think this needs to be reversed. Like, instead of build, it's chars how to insert. And then this needs to be above it, 12C. Because you append. This also needs to be in reverse then, I think. str. That's not right. Well, where's the C? Return 4. Wait, return. Hold on. Okay, guys, this is super confusing. What the hell is going on here, dude? Over this right here. Am I tripping? What is going on? C3. That's right. But then all the other ones just don't want to work. Okay, print. Previous and then count. Oh my god. Okay. C3B1. See, why is it? This is not right. Oops. That doesn't make any sense. Why does B equal 1 though? That's what I don't really understand. Maybe I'll do chars. Man, this is tricky. Why is it B1? It should be B right here, and then it goes here, and then it's B again. Let's put it at the start. I feel like this should work, guys. Like, I'm not gonna lie, but I'm not really entirely sure what's going on. Like, why are we just... Why is it A? It just skipped this character. C1, 2, 3. Right? Because it's here. And then it gets to B. Oh, because it's being moved. Wait a minute. I can just build it in build and then append it at the... insert it. Like I was doing before. Hold on, guys. Hold on. Give me a sec here. Give me just one moment. Hold on, print. Build. Yeah, okay. And then for C in build, chars.insert. Does that even work? Does it need to be backwards? Yeah, it does. Okay, so for I in range 0 to the len of build. Wait, nope. Of build -1, -1, -1. Do I need this? Yes. Okay, let's see if that submits. I'm not sure if this is how you're supposed to do this problem, bro. I'm not gonna lie. But there's no way you want me to modify while I'm going through it, bro. Like, you want me to add I, you want me to do all this horse shit. Like, I don't want to do that. Easy program to implement beats in 3 milliseconds. Shut the... 2 pointers. Oh, boy. This was a 2 pointers problem? Oh, my God. Of course it was. Of course it was. While I is less than length of chars. And chars. I mean, this is pretty close to how I did it, but he just did it in place. Like, I'm not gonna lie, this is one of my weakest things, dude. Doing like string shit in place is like fucking hard. While I is less than the length of chars and chars at spot I equals letter. I don't understand this code. Okay, I get this. That's easy. That makes sense. Why is count 0 here? While I is less than length in chars. Okay, that makes sense. Okay, that makes sense. Okay, so now, okay, that makes sense. Chars at spot ants equals letter. Man, I would have never. I mean, I get it, but like, that's a hard solution to come up with. I mean, okay, it's not hard. Like, this is a medium solution for sure. But man, that's tough, dude. That's tough because like I didn't recognize the fact that like this right here, the compression will always be shorter or the same length as the initial string combination. So that's why you're able to do it in place with no problems, because it never catches up, and that's why it never screws your. That makes sense, dude. Honestly. Okay, I'm gonna try to do his solution because I think it's important. I don't want to build bad habits, but the way he did it is like L equals 0 and R equals 0. I don't like how we did that. While R is less than the length of chars. Okay, I'm gonna try to do it without looking. So like the current letter is chars at spot I, and basically wait. Wait. I want count equals 0, and while it's R. While R is less than the length of chars and chars at spot R is equal to letter, then you do count plus equals 1 and you do R plus equals 1. Right? That's cool. So then you're gonna get to here, right? And count is gonna be 2, basically. This is where you have the left pointer. So the moment you exit this while loop, you know that it's different. So then what you're gonna do is chars at spot L is equal to letter, which it already is, or something like that, I don't know. And for num in str count, does it need to be backwards? No. We're gonna do L plus equals 1, and then we never even have to check the bounds because of the thing I talked about earlier about how the compression will always be shorter than the like full length, which I guess is the meaning of the word compression, but whatever, bro. Chars at spot L is equal to num L plus equals 1. And then Return L. Oh, if, right. Right, cannot forget that. Yeah, I mean, this is like... What? I'm done. Okay. No, this is not slower than the solution from before. I promise, bro. There's no way. Okay. So what is it? String compression 2. I'm not doing this, bro. I'm not doing it. I'm not doing it. I'm not doing it. 28 dislikes. Okay. Is it not easier than the one I just did? Okay, well, let's do a build. Count 4C in Word. Oh, we need a previous, right? Cannot forget the previous. Okay. Is it not the same code? Why is it not the same code? I'll fix this up if it is the same code, obviously, but you get to here. Oh yeah. Ah, oops. Nope. Okay. That's weird. That's weird. Oh, because I never said it. Oh, oops. Prev is equal to C. My bad. Oh, and I forgot the condition. Whoops. If count is equal to 9. Wait, I did remember the condition. Why did it do that? Oh, because of this one right here. Okay, I'm just saying right now, string compression 3 is easier than both 1 and 2. I don't know what the hell is going on in this example. Run length. Okay, I mean, that makes sense. I mean, that makes sense. Given a string S and an integer K, you need to delete at most K characters from S such that the run length encoded version of S has minimum length. What in the... That's not happening. I mean, okay, I mean, I may as well just do it, honestly. Gotta start doing the hard problems, even if I don't really want to. Let me just look at this real quick. I mean, this is tricky because, like, input s equals this bullshit. The thing is, it's like, okay, this one, you have to delete the most b's because then you combine these a's into one shit. And, like, sometimes that's the case, sometimes it's not. But this is tricky. Like, does it make sense to first convert it into this and then figure it out? Is this a dynamic programming problem? That is my question. I feel like it is for some reason. But I'm not really sure why I think that. Like, I just think that and I just... Input s equals a. I mean, I just have no idea how to, like, find that you delete both these b characters. Like, without, like, brute forcing it, obviously, which we're not going to do. Even though s is only 100. I mean, that's the thing. If you convert it into the format... Because I feel like there's... No, but this case you delete... Then you have to deal with these 11 cases, bro. Nah. Why is Loki impossible, though? It is dynamic programming, dude. It's DP, bro. It's DP. Hold on, let me just look online if... Oops. If, like, there's a Leetcode video on it before. No. Oh, there is a Leetcode video on it, and it's 19 minutes long. Okay, well then I want to do it because there's a Leetcode video on it. But I have no idea how the fuck I would do this, bro. Dude, I have no idea. Like, I genuinely have no idea. Use dynamic programming. Kill yourself. The state of the DP can be the current index and the remaining characters to delete. Having a prefix sum for each character can help you determine... Having a prefix sum for each character can help you determine for a certain character. See? What? I don't know what that means. I don't know what that means. Whoa. Man, this might not be worth my time, dude, but similar questions. Cap. Dude, I don't even know where to start with this, bro. Having a prefix sum for each character can help you determine for a certain character C. Bro, I don't know. This guy's an MIT student. What the fuck? What the? Okay, I'm not gonna lie, guys. How are you? Wait, what? That doesn't add up. This guy has one. Oh, and that's why. This guy has 1,000 problems solved, and I mean, top 10% isn't bad. No, for 1,000 problems, top 10% is pretty shit. I'm not gonna lie. But he also goes to MIT, so all right, let's check his profile out, guys. Let's check it out. Freshman at MIT. He's been a TA. Is he a? No, he's a Menlo School. Okay. That's the GOAT right there. Never mind, I lied. He's the GOAT. I take everything I said back. He's the GOAT. I have no idea how to do this, guys. I think I'm going to watch the Leetcode video and then just not solve it. Just to kind of get me thinking. Because I'm already bad at dynamic programming, you know. So let's just watch this video.
Hey everyone, welcome.
Yeah.
I'm back and let's write some more neat code today. So today let's solve the problem, string compression 2. I'm not gonna lie, this is definitely a really hard problem, easily the hardest of the month. So don't feel bad if you are not able to solve it. The premise of the problem is that we can compress strings by taking multiple consecutive characters that are the same and condensing them into the character and an integer. So this tells us that we have 3 consecutive A's. If we had 4 consecutive A's, we would do this. So you can see that we can take a long string like this one, like 6 characters maybe, and then condense it into something that looks like this. So just 2 characters. Now we could also condense 2 characters down to A2, but that's not really an improvement. And when it comes to single characters, we're not going to condense that like into A1 because that would be doing the opposite. We're actually making it longer. There are a couple things that are worth considering. For example, if we had 10 A characters, that would then be condensed to this, A10. So it is condensed down like to less characters, but this is 3 characters. And suppose we even had like 100 A characters, then we would make it A100. So that's 4 digits. This is as large as we have to worry about in this problem because I think we're guaranteed that the input string is going to be less than or equal to 100 characters. But this is part of what makes this problem hard. There's a lot of little things like this that we're going to have to consider. So now that we kind of know the background on compression, what exactly are we supposed to do in this problem? Consider this input string and consider the integer k equals 2. We are allowed to delete at most k characters from the string, but we don't have to eliminate k characters. We could eliminate 1 if we wanted to, but in this example, we can eliminate at most 2 characters. So let's say we did this and this, which just happens to be the answer. But why is this the answer? Because now, if we take this string and then compress it, we end up with a 3C3. So the length of the string now, after it's compressed, is 4. This is the deletions that we do to minimize the compressed string. If we deleted a couple other characters, if we deleted C and A, we would end up with A2, B, C2, and then D. So in this time, the length of the compressed string is 6. It's not minimized. So what we want to do is basically do the deletions such that we minimize the string after it's been compressed and then return the length of that compressed string. My mind initially went to a greedy solution.
Yeah, me too.
Because you probably want to delete, like at least from this example, it's kind of telling us you probably want to delete the standalone characters that don't have like multiple consecutive characters that are the same. Because we know that like this chunk, we could delete from it, but it's not going to reduce the size. We're just taking it from being A3 down to A2. So maybe we should always just delete characters like this. That might be a greedy way to do this. Unfortunately, that won't always work. And the reason is because doing it that way, we could maybe use a heap. We could maybe sort these based on like the counts. It wouldn't work because what if this block wasn't all C's? What if it was A's? That type of greedy solution does not consider that when we delete a character like this, we're actually creating a new long block of consecutive characters. So for us to be able to solve this problem, as we like go over this string, we are going to need to kind of compare consecutive characters. And also we're going to need to know the length of the string after it's compressed. So that makes our job pretty hard. So now let's kind of think about this from a brute force perspective. Even that is not easy, I'm going to admit. So that would kind of mean making decisions.
Dude.
And the decision as we...
Was that in your bathroom?
Let's say iterate over this string from left to right. That's usually a good first approach. And if that doesn't work, we can kind of think about it later, but I'll tell you that that probably is going to work in this case. Now let's just go iterate over character by character and consider, let's delete this character or let's not delete this character. So that's a very naive way to think about it, but it technically does work. But if we do that, and I'm not even going to try to draw the decision tree in that case because it's going to get really complicated. But if we do that, one thing we have to worry about is still maintaining the lengths of previous consecutive characters so that we can determine the total length. And for us to know about those consecutive characters, we should, as we like move our pointer I, which is going to tell us what current character we're at, we should probably compare it with the previous character just to know if like our streak of characters has increased. Has it gone from 2 up to 3? And the edge case that I mentioned earlier, where it goes from, let's say, 3 consecutive characters all the way up to 10, that's special because now the length of the compressed string has increased because we went from like A9 up to A10, which is another digit in the string. Now, another observation that I kind of want to make, look at this streak over here. We consider the case where we delete the first A. Then we consider the case where we delete the second A. And it's fine when we're deleting both of these, but why would we delete the first A? That's one possibility. And another possibility is save the first A and then delete the second A. These aren't different in any way. Even if this A didn't exist, these are not different in any way. So what does that tell us? Well, I think we'd probably pass the solution either way, but that tells me that when our pointer is here, we're at the first A. We can delete it, fine. Okay, now when our pointer gets here, and we're always going to compare, we're going to look back and check, okay, it's the same as the previous character. So we know we already considered the case where we deleted an A. And while we do have a deletion left, we can consider the case where we delete both A's, but we don't need to consider the case where we only delete one A. And the way we will be able to detect that is we're going to actually be keeping track of 4 parameters. One, of course, is K, the number of deletions we have left. The second one is going to be I, the current index that we're at. Another is going to be the previous character, of course, for us to compare it. And second is going to be the previous count. So the number of consecutive times that this previous character has shown up before. So with these 4 variables, the 4 parameters, when we get here with I at this character, we will know whether we deleted the previous one or not, like in that branch, if the previous character is actually now set to an empty string.
And this is
because
so
if we
lost on me.
delete this, then when we shift our I pointer here, we can't say, oh, the previous character was actually A. No, we deleted A. So we're not going to tell the next recursive function call that there was a previous character. We're going to tell it there was nothing there. There was an empty string, and the count of that is 0. I know this is really, really abstract, but it's going to make a lot more sense when we probably look at the code solution. But for now, I think the last thing I'm going to mention is that we're going to have 2 main cases in our recursive function. And eventually, we're going to add memoization to it using those 4 variables.
I don't even know what that means, bro.
But most of that will make more sense in the code. But the
It's
2
over.
cases we're going to have is when the adjacent characters are the same and when they're not the same. If they are the same, that means we are now counting a streak. Like we're at this character, we looked at these 2, they're the same, or maybe we're at this character, these 2 are the same. And in this case, we are actually not going to delete. Because believe it or not, in this case, there's no need for us to consider the deletion. In the other case, where we find that the 2 adjacent characters are not the same, that is when we do consider the deletion. So for example, when I is at the first character, the previous character we will say is an empty string. In this case, they are different. So we consider both possibilities, one where we keep this character and one where we delete this character. Next, when we get to this guy, we will reach him in 2 different ways. One where we have deleted this, in which case the previous character is an empty string, and the other case where we did not delete it, and these 2 characters are the same. In the first one here, we will do 2 possibilities. We will delete the character and we will keep the character. So it does give us all the possibilities. Now also, in that case where the 2 characters are not the same, if we were to keep this, then we call the recursive function on the rest of this string. And of course, they will know that this character does exist, but we will then say 1 plus the recursive call, which I think I'm just going to call count or maybe DFS. So in this case, when we keep the character, we will do that +1. You might be thinking, well, if we do that +1 every single time we keep a character, for example, here, when we keep this, we do the +1, that'll work because this compressed is going to be A2. But when we get to the third character, this compressed is going to be A3. If we do a +1 3 times, that's probably not going to work. But that's why we're only going to do the +1 in the case where 2 adjacent characters are not the same. When they are the same, you're going to see how I'm going to handle that in just a second. But now let's get into the code. Okay, so I'm going to start out with just the brute force solution without any caching. So I'm going to have a helper function. I'm going to call it count, and it's going to take 4 parameters. I, of course, the index that we're at, k, the number of deletions we have left, previous, the previous character, and previous count, the number of times that previous.
Guys, we're just watching this, okay? I am not going to write this out. I just want to kind of see it, get myself thinking a little bit, just see what's going on. Cause like, I'm really confused, but we gotta kind of dip the toes a little bit. So
character showed up consecutively. So before we implement this, let us actually call it so we know how it's going to be called. It's going to start at index 0. K is going to initially be just what K was as the input parameter. Previous is initially just going to be an empty string, and the count of that is just going to be 0. Okay, now before I even get to the base case, I'm actually just going to implement the recursive case. So I talked about how there are 2 main things that we're looking for. Are the 2 consecutive characters the same, or are they different? The case where they're different, I think, probably makes more sense. So I'm going to start with that. There are 2 possibilities, one where we delete and the one where we don't delete. So let's implement both of those. How would the recursive function be called in that case? If we're deleting, well, we're definitely going to be at the index I + 1. The number of deletions we have left is going to be decremented by 1. The previous character is going to actually stay the same.
That makes
because when
sense.
we're deleting,
Yeah.
we're actually deleting the character
Yeah.
at s of I.
That makes
so
sense.
whatever the previous character was, even if it was the empty string, is going to stay the same
Yep.
if we deleted the current character. And the previous count of that is also
Yep.
going to stay the same
Makes sense.
if we were to delete the current character. What about the other case where we do not delete? Well, we're still going to be at I plus 1.
Yep.
K is going to stay the same in that case. And now the previous character is actually going to be S at index I because we didn't
Yep.
delete it. So now it became the previous character.
Yep.
And the count of it is going to be 1 because we know that the current character is not the same as the previous character. So the streak is just starting. And
Okay.
also, if we were not to delete that character, we would do a +1 like I talked about earlier because this is a new character. It's the start of a new streak. So whatever the result of like the length of the optimal compression is going to have one more character now in it, plus whatever the remaining compression ends up being. So
I don't really understand
among
that, but okay.
these two, we want to get the minimum of them. So I'm going to do that just like this, passing them both in, not forgetting to put a comma here because they're comma separated. And I'm going to assign this to a variable result. This is the entire case where the two adjacent values are not the same. Now let's consider this case. First of all, what would the recursive call even look like? Let's just start with that. Well, we're going to have I plus 1 as per usual. We're not doing any deletion, so K is staying the same. And the current character and previous character were the same. So here we can either put previous or S of I. I guess I'll do S at index I. And previous count is going to be incremented by 1 because the streak just increased. I guess I can rename this to previous if that makes it easy to understand. But is this enough? Do we just now set the result equal to this? Well, doesn't the length of the streak tell us anything? It kind of tells us how much we should increment this by. Like here we had the +1 because we knew that was the start of a new sequence. But now the sequence is going to be longer than just 1. Like that's guaranteed. It could be 2, it could be 3, it could be 10. We don't know. So a naive way would be to do something like this, to convert previous count +1 into a string and then get the length of it. For example, if we had
Is that
10,
not okay?
for example,
Yeah, I
as
mean, that's what I
previous
would
count
do.
+1, if we convert it to a string and get the length of it, we'll say, okay, there's 2 digits. And then we could add that length here. But notice how this is recursive. Like if we had 100 or even just 10 consecutive characters in a row, we would end up adding that addition here multiple times. So that's not a good way to go about it. A better way would be just to detect every time we have increased the number of digits. And that happens when we go from 1 consecutive character to 2 because we get A changes to be A2. Or when we go from 9 to 10 because then we go from like A9 to A10. We increased by 1. Lastly, when we go from 99 up until 100 because then we go from A99 to A100. We're increasing the digit by 1 once again. Best way to detect that is check if a previous count is in any of these values in this array. It's either 1 or 9 or 99. And in that case, we can set our incrementer equal to 1. Otherwise, we set the incrementer equal to 0. The reason we're setting it to 1, even if it were to be 99, is because we know we're incrementing it by 1 every time it's any of these values. So once we get to 99, we already know that we already incremented it for these two other cases. So that's why here, the incrementer, we're going to add it down here. This is not easy stuff. I know for sure it's not easy to understand at all. That's why this is a hard problem. It's not really expected for most people to come up with these on their own. So this is how we're handling computing the lengths of streaks.
You think
also,
Taurus
again,
solves
the
this?
reason why we don't delete here is because we already consider the case where we delete at the beginning of a streak, which would be in the else case. We don't need to delete in the middle of a streak. And so
this is
down
making no
here,
sense,
now that
dog.
we've
I'm
done that,
trolling.
we can return the result. But last thing, what about the base cases? Well, one obvious base case is if I is equal to the length, which means it's gone out of bounds. We have an empty string. What is the length of that? Of course, it's going to be 0. So we can return 0 in that case. Another base case might be if k is equal to 0. But actually, it's okay if k is equal to 0. Because just because we have no more deletions left doesn't mean we can't count the length of the remaining portion of the string, so this does not qualify as a base case. Also remember that it's not a requirement that k equals 0. That's why we don't have to put like an additional guard here that k is equal to 0 before we return. But there is one base case we do have to consider. If k equals 0, then down here, we're allowed to execute this. We're also allowed to execute this one, but we're not allowed to execute this one.
True.
So how do we do that? We can add some if statements and stuff that make it complicated, or we can say if k ever becomes less than 0, then return a value so big that this possibility is probably already negated. So if we ever were to call this here and k went negative, then we'd end up returning infinity. So it would basically disqualify that call anyway. And it's important to put this one first, actually, because what if both of these were the case? We just went out of bounds and k became negative. Well, we don't want to end up accidentally returning 0, so let's make sure to put this one first. There we go. And last thing I want to do is now add caching. So I usually like to do that with a hash map. So here we're basically going to consider these 4 values as the key of our hash map. So here I'm going to check another base case. If this is in the cache, let's just return that from the cache. Lastly, let's not forget to add it to the cache. So down here, right before we return the result, I'm going to make sure to cache the result so we can then return it from up here. Now, this is the entire code. It's not easy at all to come up with. It's not easy to understand.
22 lines, bro.
But I hope you learned something from it. Let's run this to make sure that it works. And as you can see on the left, yes, it does, though the percentage isn't great. And I think that's just because most people implemented this with the bottom-up approach, though I think the time complexity is the same. Let's actually talk about that now. Here, you can see within here, there's no like loops or anything. So technically a function call is going to be constant, but how many times are we going to make a unique function call? Well, we can count that by taking I, which is going to be the length of S. So that's going to give us an N term here. K, which is also like the parameter. That's how many possible values this might end up having. And previous, which is going to be 26 unique characters. Well, I guess 27 if we consider like the empty string here. So that doesn't really do anything. We could put a 26 or 27 here, but that's not going to change the complexity, so I won't do that. Lastly, previous count. This could also end up being as large as the input string itself, so we can add another n term here. So basically the time complexity is n squared times k, same for the memory complexity. Thanks for watching. If you found this helpful, please like and subscribe.
That is crazy.
If you're preparing for coding interviews, check out Leetcode.io.
I don't want to check out Leetcode.io. Yeah, this is just an impossible ass problem, dog. Good one. All right, so now we just got to get to the music player project. Or maybe should I do one more? Leetcode? I don't know. I'm not doing that one, though. I think we need to do a DP problem. How much time? I have like an hour, 40 left? Why is this not pinned? Yeah, okay. Okay. And 59%. Like, people are good at Leetcode, dude, I swear. Because, like, I just look at this problem and I don't even, like, really know where to begin. Buy, sell. So you're up one. Cool down. Buy, sell. That makes sense. So I know it's 2D. I know it's two-dimensional dynamic programming from the Leetcode roadmap, but okay, like on each square, I can choose to buy, do nothing, or sell, right? On each thing. And I can only sell if I have a thing. I think, right? So that's something to keep in mind, I guess. Like, I'm just gonna start drawing shit, dude. See if that helps me go anywhere. Like, if I have one, two, what would be up here though? Like, what would be these things? I don't know what I'm drawing, guys. I'm just drawing squares because maybe the Lord will speak to me. Honestly, it's probably something like this. Just going based off like the other problems. Something like this. I don't know. And like these squares are empty because you can't buy and sell on the same day or some shit. So it's like you buy this and then you sell this. So this is like one or something. What's the optimal route? Buy, sell. Okay, one. And then I cool down. I buy 0. And I sell it at 2. 2. So like 0, 0. Maybe? I don't know. Oh, I guess this is not possible too. If this is sell, then this is not possible. This is not possible. Like if this is, okay. Buy, sell. This is not possible. This is not possible. So only these are possible. So you'll never buy in the last one. That makes sense. So what if I choose to buy here and sell here? That's -2. Choose to buy here, that's 1. Choose to buy here, that's -1. Choose to buy here, sell here, that's 2. That's 0. Choose to buy here. Oh fuck, you see this can be 3 then. That's the problem. This could be 3. And that's why this whatever the hell I'm drawing is just stupid as fuck and doesn't work. Well, I guess you can just buy here. Like this is a valid solution. You can just buy here and sell here. Okay, well that's this. I don't know if this table is helpful at all. Because it's like this is a valid solution or something. Man, I just can't visualize this table. Like I don't really know. I don't know. I don't know what I'm doing. But I think it makes sense that like this whole part of the table this is off limits. Where's the bucket? That's all off limits, right? So that's cool. But like then what? Okay, then you have buy one, sell one, fucking who knows, bro. Okay, like what are maybe all the possibilities of here at buying at 1? 2 minus, so this is 1, this is 2, this is -1, this is 1. 2 is 1, -2, 0. 3 is -3, -1. 0 is -2. And you just don't buy that at all. And what does this table tell me, bro? Absolutely nothing. I'm really just trying to like look for a pattern. I ain't finding it, dog. I ain't finding it. Yeah, I don't think that helped me either. God damn it, dude. Is this not like house robber though? It's like if you're gonna buy here, oh, these are all your options. If you're gonna buy here, you take the max of whatever this shit is. So it's like, okay, at the 0, right? You take the max of whatever these 2 are before this, right? Because we're trying to get 3, right? In this example, which is buy, which is sell right here. And then Oh, this is not -2. That's why I was confused. Hold on. This is just 2. Yeah. But like looking at this table, this table tells me absolutely nothing. Come on, buy or sell. Buy. So I buy it 2, sell it 2, or buy it 0. Whoops. Why is it spelled so? So I buy it 0, sell it 2. Now I need to check these two right here, which is the greater one out of this one. Which it would be this one right here. So the way I'm pretty sure this is supposed to work, guys, I have no idea. I'm totally guessing. Do I look at all 3 of these? I'm pretty sure I keep the... But then I can't buy here. Oh, maybe I'm looking at the wrong thing. So, okay, I get the max. No, I can't be greedy because then I'm going to take this one. Oh, maybe that's... No. Hold on. No, I'm definitely close to the solution. I feel it. This triangle shit is really messing me up, though. So, like, I'm buying it 1. Right? Buying it 1. So, this is my only option for this first thing. Right? And then I move to 2. Okay, I'm buying it 2. I can either have a 1 or a 2. Right? So, right now my max is... My max is 2 right now, I guess. I don't know. Right? It used to be 1. And then it went to 2. And then now I'm looking at the 0. And I have to do... Well, I'm buying it 3. Okay? I'm potentially buying it 3. And I can only look at this one. Because it's 1 away. Because the cooldown situation. And then I keep my max of 2. And then I look at this one. Where I buy it 0. And then I have no idea what the fuck I'm looking at. Nah, this isn't right. Man, how is this 2D though? Like I'm thinking just 1D and it just kind of works in my head, but like not really. Man, I don't know what I'm doing. No, like you look at this one and then you're only allowed to like look at this one. Like you're only allowed to like look here. Like if you look at this one, you're only allowed to look. Dude, I don't get it. You're buying it 1, selling it 2. You're buying it 1, selling it 3. Like, is that even helpful? This is -2. Wait. Oh, no, it's not. It's 2. Maybe it'd be helpful if... Hold on, guys. Like, I'm really just trying to solve this myself before I look at the solution, but... It's not looking so good. 1, 2, 3, 0. Right? We never buy it the last one. And we never buy it the first one. So it's 2. Hold on. It's like 3 here. I'm definitely doing this wrong, dog. One, two, three, four. 1, 2, 3, 4. But this doesn't make sense because I can sell at all of these places. I can sell one at 2. I can sell one at 3. I can sell one at 0. And I can sell one at 2. So is it like, oh, it might be like this. Right? I don't know. So these are all the valid. So here, let's try this one more time. And if I can't do this, then we give up. Dude, why do I keep spelling buy like a freaking foreigner? All right. So -1. Maybe let's make them orange or something different. Spice it up. -1. Oh, wait, no. It's 2 minus 1. So I would gain profit 1, profit 2, profit -1, profit 1. 3 minus profit 1, profit -2, profit 0, -3, -1, profit 2. Okay? What does that tell me? The problem is if I do this, wait. If I do this right here, then this, what's not allowed? Then nothing else is allowed after that. This is all off limits. All of this is off limits. So it's 2 over. So if I buy one here, then this is all off limits. And I can only choose from here, which that's the right answer. I choose so if I choose this, the next 2 are off limits. So I choose the max. Do I choose it? Would I choose it here? I don't fucking know, bro. No. If I did that, hold on. Bro, how is it 60%? Like, am I stupid? I don't get it. How are people solving this so easily? I don't get it. Like, I just don't get it. I just don't understand it. I don't get it at all.
Hey everyone.
I don't get it. I really don't.
Hey everyone, welcome back,
I
and
don't.
let's write some more Leetcode today. So today let's solve best time to buy and sell a stock with a cooldown. And this is actually a very interesting problem and a very challenging problem, but honestly, I'm gonna make this problem look like a joke today. And that's not because I'm really smart. It's honestly only because I know how to draw a picture. I'm sure you guys know how much I like drawing pictures for Leetcode problems and how helpful they are. And this problem is a perfect example of why exactly that is.
I couldn't draw it.
So let's get into it. We are given an array of prices. The price at index I just represents the price of a given stock on the ith day. And our goal is to maximize the profit that we can achieve. And the complicated part is that actually we can make as many transactions as we like. We can buy a stock and then sell a stock. But there are a couple restrictions. The main restriction here is that we can't buy a stock and then sell the stock on the next day. We have to have at least one day in between called the cooldown day. Now, we could have one cooldown day, but we could actually have multiple cooldown days if we really want to, right? Because we have a choice of how many transactions we can complete. And the other restriction here is that if we buy the stock, let's say...
Dude, I almost just want to look at the drawing just to, like... What the fuck? Should have drawn
on
decision
index
tree.
0, right? We buy it for price 1. We can't just buy it the next day as well, right? We can't just have infinitely many. We can only have one share at a time. Basically, that's what they're trying to get at, right? We can't buy and then buy and then buy. We have to buy and then sell and then rebuy. So in this example, with this array of prices, the result happened to be 3. 3 is the max profit we could get, and these are the decisions we would make to result in the output 3. We buy on the first day, we buy for 1, we sell for 2. That's a profit of 1. So far we have a profit of 1. We cool down on day 3. So we cool down, we buy it for 0 the next day, and then sell it for 2. So that's a profit of 2. So the total profit was 3. So not too bad, but the real complicated part about this problem is that we have so many choices that we could make. And that can get really complicated unless, of course, you draw a picture. So let me show you how, with drawing a picture, we can solve this problem in linear time. So like I said, there's a lot of decisions to make, so let's try to draw out those decisions.
I'm going to draw it before and see if I can solve it.
The thing here is we can either buy or we can sell. And we can only sell if we have already bought the stock before. So when we start out at this array, right, we start at day 0. At this point, at the beginning of the array, are we buying or are we selling? Of course we're buying because we don't own the stock yet, so we can't sell it. So that's one part of the state that we have to kind of keep track of. Are we buying or are we selling? And it's not too hard because it's just a Boolean, right? It's true or false.
But you can not buy, though.
And initially we're buying. So, we have a choice at index 1, right? We can buy. So of course...
Or you can not buy. I don't understand.
One decision is buy. If we buy the stock on day 0, it costs 1. So if we do buy, what's our total profit so far? Well, buying costs money. So our total profit so far if we buy is going to be negative 1.
True.
Now, are there any other decisions we can make other than buying? Well, we definitely can't sell yet. We don't own anything. But we can definitely do a cooldown. Now, if we do a cooldown, then our profit is going to be 0 so far. And by the way, let me just draw a little 0 up here because when we initially started our profit.
All right, let me try drawing the decision tree. Okay. So we got buy. Hold on, what's the array looking like? Can I take a picture of it? So we buy What? Oh my. Of course. Of course. Okay. That's cool, bro. I love this paint. Okay, I'm looking it up. What does Leetcode? Oh my goodness. Okay, so you have this 0, right? You start at 0. Can I make it? I go here, I buy, which is -1. I cool down, which is 0. I sell, which is then profit is 1. I cool down, which is -1. I buy, which is -2. I cool down, which is which is 0. Okay, this is going to be 0 all the way. Okay. I buy. I have to cool down. I literally have to cool down from here. C1. Cool down. I can sell here or I can cool down. On 1, 2, 3, 0, 2. So I'm at 3. So I can sell here, which would be put me at 2. Wait, do I add 3 to it? I do. I add 3, which would be 2. I cool down, which is -1. Do I sell here? Is that what I did? Did I sell here? Sell, cool down. I have to cool down here. I can cool down again. Or I can buy at, so I'm at -3. I can cool down. I'm at 1, 2. I don't know what's going on, bro. I don't get it. I don't get it.
It was also 0. Okay, now on the left path of the decision tree, what choices can we make now? Can we also buy and do a cooldown? Well, we already bought. We can't buy again. We have to sell now. Technically, we don't have to sell, but that definitely is one of our choices. The other choice, of course, is cooldown. So as you can kind of tell now, we always have a choice of cooling down, right? The main choice that we're going to be determining is, are we buying or are we selling? The other choice can always be cooldown. We don't have to do anything. But if we do sell on the second day, you can see on the second day the price is 2. So by selling, we're basically doing a +2 operation, right? Initially, we had -1. We're doing a +2. So that means our total profit, if we sell so far, is going to be +1. So that's pretty good. Now, of course, if we cool down, the profit is going to stay the same, meaning -1. Now, let's quickly draw the decisions on the right side of the tree. If we cool down, then we can't sell because we haven't bought anything yet. So the same decisions will be present as the original decisions, basically buying cooldown over here, and the other decision is going to be buying. So here, if we buy, we saw that initially we had 0 as the total profit, but if we buy on the second day, that'll be a -2 operation. So our total profit so far will be -2. If we cool down, of course, it'll just stay 0. So now we get to a kind of interesting case. After we have already sold, then what are our decisions? Can we buy and then also have a cooldown? Well, the answer is no, and the reason is because remember, after selling, we are forced to have at least one cooldown day right after selling. So basically just pretend like we skipped a day, right? We had a forced cooldown day, right? That's our one decision. And we can't make any other decisions here, right? This is our decision. We're forced to do a cooldown after selling. But after doing that, we know our profit is going to stay the exact same, +1. After doing that, though, then we do have a choice of buying or having another cooldown day. So we can buy, or we can have another consecutive cooldown day. If we have another cooldown day, of course, our profit is going to stay the exact same, +1. But if we buy, well, first, what day is it? It's the 4th day now. It's the price is 0. So if we buy, it's going to cost us 0. I wish I could buy stocks for a 0 price. But in this case, of course, if it costs 0, then our total profit is just going to stay the same. So we can stay at +1. Now, let's continue on this path. Last decision we can make is either selling or having another cooldown day. Of course, if we sold, well, we're on the 5th day, the last day. The price is 2, so we'll make a profit of +2. We were already at +1, so 1 + 2 is going to be 3. That's going to be our total profit. If we took this chain of decisions, right? If we bought, sold, had a cooldown, then bought and sold again, this is what the profit would be. Of course, every path in this decision tree is going to have a different number, right, for the total profit so far. And of course, we want to return the maximum. And by the way, if we had the cooldown day instead on the last day, then our profit would stay the same. It would be +1 as opposed to +3. And just imagine that, every leaf node of this tree has some different number, and among all of those, we want to return the maximum. So among these two decisions, between 3 and 1, of course, the value we are going to return when we implement this solution recursively, the value we're going to return is going to be the +3. We're just going to take the maximum of these two and return the max. So I really hope looking at this picture makes the solution understandable for you. The downside to this solution, though, is the time complexity. You can see that the height of the tree that we're making is going to be n, where n is the size of the prices array. And the number of decisions at every point we can make is up to 2 decisions. So the overall time complexity is going to be 2 to the power of n. But we can actually use a very simple dynamic programming technique called caching in this case. And by doing that, we can reduce the time complexity to big O of n. The reason why is because the key for the caching that I'm going to be doing is going to be the index, right? The index of what position we're at in the prices array. The second key I'm going to be using is a Boolean for buy or sell. I want to know if we're buying or are we selling. It's a binary decision, so we can just use a Boolean for that, right? If we take this key value, how many possible values could it be? Well, the index I, there's n different possible values for it. This buy or sell state is going to be 2 different states for it because it's just a Boolean, right? So if we take n times 2, we basically get 2 times n, right, which we know is just can reduce to big O of n. So in this case, if we use caching, the time complexity will be big O of n. The memory complexity will also be big O of n because we are caching. If you're not familiar with caching, I'll be explaining it right now as I go into the coding solution.
I don't get it.
Okay, so now let's write out the code. You can see I already wrote out a few things. One is just a comment kind of explaining what we're going to be doing. We're going to keep tracking of the state. whether we're buying or we're selling. If we buy, we're just going to increment the index by 1. If we sell, we're going to increment the index by 2. Reason is because we remember we have to take a cooldown day after we sell.
That makes sense.
And remember, we are going to be using caching, a dynamic programming technique. So the easiest way to do a cache is just use a hash map. So that's what I'm doing here with Python. And just a comment, what I'm going to be using as the key value of this hash map is going to be the index I that we're at in our prices array, and a Boolean, which is called buying. It's going to be true if we're in a buying state, and it's going to be false if we're in a selling state. And the value of the hash map is just going to be the max profit associated with this key value. So now let's get into it. I'm going to be writing out a recursive function, DFS. I'm going to be writing the function inside of our root function because it's just easier that way. We don't have to pass in every single parameter. We don't have to pass in the prices array. We don't have to pass in our DP cache. We only have to pass in our index and whether we're buying or we're selling. So first thing with recursive functions I like to do is just write out the base case. So we know that the main base case is going to be if index goes out of bounds. So basically if index is greater than or equal to the length of the prices array. I didn't really cover this base case in the drawing explanation, but I think it's pretty self-explanatory. If we go out of bounds, basically if we have an empty array of prices, what are we going to return? Well, we can't make any profit off of that, so we're going to return 0. Okay, so that's great. And the other base case I just want to quickly mention is the case that if this pair of values, this I and buying pair, has already been computed before. So basically, if this is in our DP hash map, initially our DP hash map is empty, but if this is in our DP hash map, then we assume
If I buying in DP,
that the max profit associated with this key has already been stored, so then we can return that, right? So in DP, we can just use this key value and then return whatever that max profit we stored was. Okay, so now for the actual decision that we can make. And remember, that decision that we make is going to depend on only one thing. What state are we in? Are we buying or are we selling? So it's a binary state, right? So if else. So let's start with the buying. So we know in the buying state, we can do two things. We can buy or we can have a cooldown day, right? What's going to be the profit, the max profit associated with each of these? Well, if we buy, we're going to recursively call DFS at index I plus 1. And what's the state going to be? Are we going to
false.
leave buying as the same? Of course not, because
buying?
if we just bought, then we're in the opposite state. We're in the not buying state. So in Python, this will literally just take that Boolean value and negate it. Or in other languages, you could just do like the exclamation mark, but I'll leave this as is. So that's how the recursive call is going to work. Pretty straightforward. But the only thing is, if we bought, doesn't that affect our profit so far? Remember, that's what I was keeping track of. So if we bought, we have to subtract the price of what we just bought. We bought the index on day I, so that's what we have to subtract from the total. This will tell us what the max profit we can get from the remaining array starting at the not buying state, and this will tell us how much it actually costed us to get to this state in the first place. Similarly, we'll do the cooldown state, which is slightly easier because all we have to do is do I plus 1. And in this case, the buying state actually stays the exact same because we did not buy. So we're still in a buying state and we don't have to subtract anything because we didn't spend any money. And last but not least, don't forget to cache the result. So now we have our result. So I'm going to use our key value I and buying. And remember, we took two decisions. Among these two decisions, what do we want to know? We want to know which one created the max profit for us. So let's just take the max of buy and cooldown and then assign that to DP. So this is where we are actually caching. So if we
I buying, I mean, I would have never figured this solution out by myself, guys. I'm just going to keep it 1,000.
we cache the solution and then we try to recompute that solution up above, then we're going to end up returning it instantly rather than going through all the recursive calls over again. Okay, so that's really the bulk of the problem. Last thing we have to do is handle the sell case. So if we sell,
I'm not gonna lie, guys, I just don't get
we're
it.
going to do DFS. And remember, if we sell, we're actually going to increment the index by 2 because we have to take a cooldown day. And if we sell, we also have to negate the value of the Boolean And you know, you can do what's readable for you. If you want to change this to, you know, set the buying state to true now, you know, whatever's readable for you. I prefer just setting it to the negation. But instead of subtracting the price like we did with buying, we want to actually add the price, because if we sold, that means we made some money. So we can set, you know, add the profit of this. Notice I forgot the S up above. And yeah, so that's one decision. And the other decision is just the cooldown decision, which we can literally just copy and paste from up above, because a cooldown is just skipping the day, and it'll be the same in both cases. And I'm going to copy the DP assignment up above, because the only difference if we sold is we're going to take the max of sell and the cooldown day. And if you want to save like one line of code here, you can probably just take one of the cooldown functions, move it outside of the if-else statement, and then delete the other cooldown, which I guess I'll do for you, but I don't think it's really that important. But yeah, once that's done, what do we want to return? We want to return whatever the max profit was. We luckily stored that in our DP, so we can just return just like this. And believe it or not, that really is the
I don't get
entire
it at all.
function, but we don't want to forget to actually call that function. So let's call our DFS starting at index 0. And initially the buying state is true because we are buying when we start out. So let's run this to make sure that it works. And as you can see on the left, yes, it worked.
I don't get it at all, guys. I think I have to come back to this problem. Dope.
Okay, let's...
I'm gonna save this for later. I think my recursion skills are really weak, and that's why I'm having problems with all of these problems. Because like every time he does the recursive call, I just get confused. So I need to work on my recursion skills. Probably. I don't know. I'm not feeling too motivated after that, guys. I'm not gonna lie. That kind of makes me feel sad that I just don't even get it after watching the video. Because it's like 260 problems and I just don't get it. Like at all. But what are you going to do, you know? Man, that really sucks. Okay, I'm going to work on the project, I guess. But I'm just feeling so terrible right now. It's whatever, bro. All right. All right, let's just see what we got. Dude, I actually feel so... I feel stupid, bro. Okay. So what we got so far, basically, guys. Basically, guys, what we got so far. We have this like the song search. So it takes in the song search right here this is a music player. I don't know if that was like self-explanatory, but right, you have all the songs in this. So basically the song search reads all the songs in the folder and then puts them here, right? And you can just like look them up, you know, and it works. It's a try, so I can easily search up like if I had 100 plus here, and basically you can kind of like basically you can like um, you have a playlist, right? This is the main playlist. This just hosts all the songs that are in the folder. You can't do anything to this playlist. You can't delete it. You can't delete any of these songs. That's on purpose because it's the main playlist, right? And then you can like have like other playlists. This one just happens to be a copy. You know, and you can like delete songs in here, you know. And then you can get errors too after you delete it. Yeah, so that's cool. I thought I fixed that error, I won't lie. Index 1 out of balance, bro. What? I literally thought I fixed that error. What? Uh-huh. Index 2 out of... Does it recheck it? Playlist Java 66. Wait, maybe I don't like this. I really thought I fixed this error. I'm not gonna lie. Where is this being called? Why is it dot reset? Oh, I see. So it's being called here, and then it's being... But the problem is it doesn't exist. Or some shit, I don't know. Let me just print out current song. I mean, this should just be null, right? Calls it again? Okay, hold on. I have an idea. Okay, if... What does it return if it doesn't exist? Oh, I need to handle this. How do you handle exceptions in Java? What kind of exception is it? Index out of bounds exception E. Current index equals 1 or 0. Wait, what about, wait, hold on. Wait, what do I do if it's null? Do I just get the layout? I probably just get layout, right? Or get VBox. I don't know if this is gonna work, but let's just try this. Nope. I'm looping. Yeah, that makes sense. Well, it doesn't really make sense, but what do I know? I don't understand that when I select it. What the hell am I doing that's like so special that I select it? Because it's the current song, I guess. Okay, so like, try this shit. Catch, what is it, null pointer exception. Return new H box. Fucking nothing in the H box. That should work. And it's fucking broken. Oh my god. Is it because the index was never updated? Null pointer. Oh my god. Oh, what my big thing. Handle song click. Current song dot reset. And what is it? It's a null pointer exception once more. Okay. Here we go, bro. Just do nothing, bro. Oh, and I can't pause anymore. Wait, when I deleted it, it stopped playing? I have that baked in? Wait, am I a goat coder for that? Or oh, they're all playing now. yeah, when I delete a song, it needs to stop playing. So let's make sure I handle that. Guess I just reset. Oh. So do I have the current song? Oops. Stops or reset. Okay, can I just get the curse song? Okay. So if I delete a song, it should stop playing. You guys can't hear it because I don't want to get copyright striked. So my last video got copyright striked. But then the play button disappears. Should I just reset all of them? If I delete a song, should all of them be reset? Optimally, no. But how did I get to the state where I deleted all the songs and there was still a song playing? How is that even possible? How did I even get to that state? I don't even remember. That's why. Wait, so you're telling me they're not synced? So if I go here and I play the song, I delete this song, and then I delete. Wait, what? The current song that's being highlighted is not the current song that's being played. Why did the current song change to the one I deleted? It's not good. The current song changed when I deleted it. Why? Handle song click. Like delete. Clicked index. Get VBox. What? Current index. Do I ever set it? Wait. No, I don't. This should be clicked song though. But that doesn't do anything. Like, because the index, because when I'm deleting, that's the problem. So when I'm deleting before it changes the shit. Yeah, I need to go to the bathroom. Okay, I think I know what the problem is, guys. So basically, all right, let me open up that thing right there. I don't even want to look at this, bro. Oh. Where's the new button? Nah, there's no quick new button. Like, I have to delete all of this. I don't want to do that. Okay. Because when I have like, I have this list, right? And I have song 1, 2, 3. And like, this is the current song playing. The way it's working right now is that when I delete this one, or hold on. When I delete this one, is that my thing become, hold on. I'll draw. After I delete this one, stroke, it transforms into 1, 2, right? The indices. These are the song 1, song 2, song 3. And this is song 2, and this is song 3, right? But the problem is that these numbers are not staying the same. Okay, so I think if I delete, I don't know how to handle this, actually, is what I don't know what to do. Because then this, because like this 2 right here now becomes this 2, right? Like, and then this is the song. Can I highlight shit? Oh, so I can draw shapes. Wait, let's do one of these. Oh. Where did the thing go? Command palette. How much is this, bro? $7 a month. Wait, why can't I highlight shit though? All right, whatever. The point is this is the highlighted one, right? Because this is the song I have selected. But after I delete this one, this is the one that's highlighted. And you see there's a disconnect with the ones that are being highlighted. So we need to figure out how to fix this problem. We just need to change the current index, right? Is that all I need to do? So like if clicked index is less than current index, then then current index minus equals 1. And this is let's see if that works. They shouldn't be highlighted at all. Else if clicked index is equal to current index, then current, can I just do like -1? Does that break it? No, it doesn't. Okay. Okay, so I think that I just fixed it there. Let me just commit that, honestly. I don't know if like this is like too small of a commit, but okay. Okay, now let me just test all the edge cases. I'm like paranoid this is not working. Why does it keep doing that? Honestly, I would like it if it returned like something. Like, I don't want it to return an empty box. I don't like this. Like, I want it to return this. But like, where's the actual song part of this? Playlist that is playing. Hbox. Wait, why can't I return this? Current song dot get layout. Oh, because there are no songs, so it like just get it just. Oh, and the current song is null, so I can't call this function, even though this function has nothing to do. Well, it kind of has something to do with this, but I just need the boilerplate. What if I create a new song? Dummy. Does it need a thing? It does, bro. Okay. Public song. Dummy constructor, so I can return a layout. Okay. What's this, bro? Missing return statement. Return dummy dot get layout previous next. Let's see what that does. Of course, bro. I didn't even change that much, dude. That shouldn't even fucking happen. This dot volume bar is no. Okay, well, it looks like we're gonna need to do some. Wait, what does it take? It really does take all this garbage. Oops. How do I get rid of that? How do I get rid of this? Okay. So I need a song player. Can I just make like a media player? It can't be empty? Oh. Maybe I just switch it. Hold on. Maybe I can just switch it to a different playlist or something. Can I do that? Playlist choice. That's not what I'm looking for. God damn it, dude. Dude, it would be nice if I can just take these and use them without... Can I? Public? What if I don't want to fucking initialize it then? What then, bro? Dude, I don't know how to handle this. Maybe you just can't delete the last song in a playlist or something. That's actually probably a great idea. Hold on. If playlist.size no, that doesn't work because when I create a new playlist, there's always 0 songs in it. That's stupid. Okay, my other idea is I just have a okay, empty MP3 file. Okay, I have an idea. So basically, guys, I'm gonna get an empty MP3 file. It can be really short. How do I download this, bro? Download raw file. Okay. And we're just gonna put it in here. What the? Nice. Okay, and we're gonna rename this to dummy MP3. Oh, I only have like 10 minutes left. Okay, maybe I can get this done. And basically what I'm gonna do, song dummy equals new song. What does it take? Right. Okay, it's gonna take a file, which, hold on, /songs. And it's gonna take a what? Name, dummy. Okay. No. Dummy dot get layout. Previous next. Unrecognized file structure. Whatever, dog. Is it just that? Dude. This is so funny, guys. I'm not even joking. Is it not in here somewhere? Dummy.mp3. Oh, it's .mp3, is it? I think it might be .mp3 or some shit. .get name. Wait. It might be dummy.mp3. I think I'm just... Bro, please give me a break. Like, Jesus Christ. Unrecognized file structure. What are you confused about? File? That's like where it is, no? Okay, song, file entry. Okay, I'm printing this, bro. Sao, whatever the hell this is. I'm printing. Let me get both of these, bro. What's the format, dog? Just tell me the format. Let me add them. Dude, I have to go to school. Let me copy the direct path. Like, let me just do that, and I'll do that for now. If I can. Oh boy. No, I don't want to do any of this shit. Yo, how do I get the absolute file? Copy path reference. Absolute. Of course, those wouldn't fucking work. Am I stupid? I need to make these dummy buttons. Well, it's low-key fixed. Wait, I fixed it. What? Wait, it literally works. Okay, to do, fix. Okay. I'm happy with that. All right, that's going to be it for me today. Class time. Peace.